And the first is going to be Carlos, then Jainam to take control of the slides anyway.
Okay.
Just in the middle.
Okay, great. It's 6:30. I think we should get started.
Yes. Welcome,
Hello,
everybody.
everybody.
We have Eve.
Yeah,
Sorry.
welcome everybody to the last day of the IETF. Welcome, good morning, good afternoon, good evening. I'm Eve Schuler, and we have Michael Welzel in the room, and we are missing our co-chair Ali, but hoping he will join us at the next IETF. I'm just trying to see if I can control things here. Yes, note well, you have seen these slides often throughout the week, but we want to continue to reiterate that hang on, am I in the right place? Yes, with the controls. I just want to reiterate that we need to note well that we need to be really respectful of all of our co-attendees. And you can read more about our policies of respect by following some of these links here. We have a code of conduct and anti-harassment procedures. And I just want to remind people that you are being recorded. And as such, you implicitly, when you turn on your mic and when you turn on your camera, you give agreement that you are okay with that. The session is already being recorded and live streamed, and it would be really helpful if when you do approach the mic, whether remote or in person, that you say your name and optionally your affiliation, and that'll help the note takers and that'll help the transcription. We also like to remind you that if any of the ideas that are being presented or discussed are associated with IPR, intellectual property rights, that you disclose that, you disclose that early. There are additional RFCs that you can refer to that will give you the full details on our policy. A reminder that the IRTF and the IETF have slightly different goals. The IETF, of course, is a full-on standardization, specification, organization. And the IRTF really is focused on longer-term research issues. And while that doesn't mean, it doesn't preclude us from creating standards, it simply means that it's not our main goal. You can read more in the primer. You've made it to the session, so congratulations. If you're in the room, physically, you can either use the QR codes that are scattered about physically to join the session or to at least note that you are part of the session, or you can join the local tool. If you're remote, obviously you're here, so we're capturing the fact that you're participating, but it's really great for us to know how many people are participating. Additionally, I would love to encourage people to join the shared note-taking part of the tool. You can get to it either through the upper banner, or you can click on the links, the many links in the agenda and other places. There's also a chat window, and I would love to solicit right now, is there anybody out there who might be willing to notate? I'm going to pause for a moment. Michael, do you see anybody in the room or anybody in the chat? Well, for those of you who do step up, if you see anything in the chat that's of interest that warrants discussion, you can either come to the mic or you can drop it into the notes. That would be super helpful. Our vision for Sustain RG is to contribute to the advancement of the internet as a fundamental part of sustainable and resilient societies and the planet through conceptual and evidence-based multidisciplinary research and collaboration. And you can read more about the group on our webpage. We have a great lineup of speakers today. We're really pleased. Most of them are remote, although there's one who's in person. We're really pleased. We've got Romain Jacob speaking about work that he just recently presented at the IMC conference. We have a joint presentation by Jainam and Carlos about ICMP extensions, carbon accounting. Jan is here. Adrian will be speaking about the augmented Petra proposal. And finally, in person, Jari is going to be speaking about a paper he and his students as well recently presented. We're really thrilled to have everybody. So with that...
Can I comment?
Yes.
Maybe it's not Jari Arkko from Ericsson.
Oh.
Oh. Oh.
Yeah.
It's Jari Manner.
No, Jari,
No, it's not Jari at all.
Jari, these Finnish names, I know they are really problematic.
It is not Jari at all. How did that happen?
But I wonder if Jari wants. But I can give my presentations to Jari also. Yeah, you want to run it? Okay, we can also do that. Jari.
Oh, he's right here. Yeah, he can take over. So you're like.
Yeah.
It's Yuka. It's Yuka.
Yuka, sorry for that.
I know they are difficult names. Sorry.
All those J's and double letters. Our sincere apologies.
But you know, we got a Finn to tell a joke. That's also something. Okay, well.
Without further ado, and with the correct speaker, I'm going to pass the baton to Roman.
So should I do the request slide thingy or?
All the slots already. Yeah. Thanks. Just a second. Doing it. I need to allow it somewhere. Yes. Oh, the slots are taken. This is because this is already being shown. Got it here. Sorry.
All right. There we go.
And I'd like to request that if we're not speaking, let's go on mute, and we don't necessarily need to be displaying our video.
All right. So do you guys see the slides? All good?
Yes.
All right. All right. So good day, everyone, respective of your time zones. My name is Romain. I'm a postdoc at ETH in Zurich, Switzerland. And here's some work I've talked a little bit about in Sustain, I think last year, maybe, yeah, I don't know exactly when, about modeling and optimizing router energy demand. I said I recently presented this actually last week at IMC. But this work has been going on essentially over the past couple of years. So the story goes back to all the academic works that try to see how we could optimize energy usage in a network. There are many of them, including some of our own works there. And essentially, the key idea is always the same. You try to turn off things in your network when you don't particularly need them. Typically, at low utilization times, you don't need necessarily all your links to be active, and you can turn some of those off. The issue with all those works, including ours, is that it kind of struggle to really estimate how much energy you could expect to save if you were to actually deploy such a change. And the reason they struggle with this is that they so far lacked an accurate enough power model for routers and network links to tell you, if I turn off this link, this is how much power I would save. Or if my traffic increased by that much, this is how much power extra I will have to pay for that traffic. And so essentially this paper is tracing down, or this work is tracing down, filling that gap. So first step, how to establish a power model, which has the granularity, enabling us to do those estimations. And second, using this newly established model to finally quantify the potential savings of link slipping. So let's get into that. Yeah, there we go. So nowadays, there are generally two classes of data that we have available. There's what the data sheets are telling us, and there are things that you can measure. And measurements can be further categorized into two subcategories. The measurements that are taken by the routers themselves, which may come from the PSUs or the PDU or whatever, or from external measurements that you would have from parameters that you deploy that are not, strictly speaking, from the router themselves. The data sheets are not very useful for our needs. They typically give you machine level numbers that are coarse grain estimates that are not really designed to tell you how much you would expect to draw, how much power you would expect to draw in practice. So we need to go and use measurement data. As I mentioned, power supply unit, and more frequently nowadays, do measure and report the power they deliver. As I'm sure has been discussed again this week. There are some standardization challenges about collecting that information, but thankfully the IETF will solve that very soon. However, there's also a bit more of a fundamental problem about this data, as it's not so clear whether we can trust the numbers that the PSUs are giving us, because historically it seems that those sensors haven't been of the highest quality possible. So that was not obviously a great news for us. And it somewhat forced us to work with external power measurements. And while doing so, kind of like comparing the internal measurements with the external ones while we were at it. We've been doing this for now a year and a half. We've been continuously collecting internal power measurements from the Switch network, which is our local research and education ISP here in Switzerland. So I'll skip the details about that. That's not really relevant for today. So with those measurements, we can hope to establish the model for the power draw of a router, which is a bit challenging because we don't really know what's in the box. And vendors don't tell you what kind of hardware you have inside and how it's soldered and so on. So we're kind of limited to what we call top-down approaches. And effectively, we work with power deltas, right? How does it work at a high level? You measure your router in a certain state, what is your baseline situation, and then you change something to the router configuration, you plug or unplug a transceiver or something, and then you measure again the power, and then you make the assumption that the power difference you observe is fully responsible or fully caused by whatever you change in the state of your router. So what do we try to change? Right, here are the different steps of the methodology we've been developing. The starting point is what we call the base power, where you plug in your router and that's it. Right? You have no transceivers plug in whatsoever. You have no configuration. You run just like the default manufacturing settings. Right? Then you start plugging in transceivers without still configuring anything. And then we've observed that in some cases, we have some change in power there already. Now, if you think about a situation where you plug two transceivers connected together and you activate only one of the interfaces, then you will start powering up the electronics of that one interface, but the IP link is not yet up because the other side is not connected. Then you activate the other side. It gives you a different now you have the full power of the transceivers. And then once you've done all this, you can start sending and receiving traffic to get some information about the cost of traffic volume on power. Obviously, it's quite a few experiments, and it's not one of each that you need to do. You need to test different packet sizes and bandwidth, because all this has an impact on power, different type of transceiver, electronic versus optical ones, and you need to do all those things multiple times. We've automated this process as much as possible, and we've made all those tools available for anyone interested in developing their own power models for their devices. Ultimately, once you've collected all this data, you can crunch those numbers together into a power model that is ultimately very straightforward. We model the power draw of the transceiver itself as a constant value, which we've validated to be fairly accurate as an hypothesis. And then for the router side itself, we have essentially the sum of four big terms: the base power plus a given power cost per interface that will depend on the type of transceivers you put in there, and the configuration. So if you have, let's say, a 400 gig capable interface that you configure at 400 gig or at 100 gig, then it will have a difference in power draw. And then you have two terms for the traffic costs. One, energy per bit cost, that pertains to, well, the physical forwarding of the bits from input to output port. And one cost for the header processing. And in practice, we found that it's necessary to really differentiate those two tasks. Otherwise, you create errors in the power estimates. So at a high level, it kind of looks like this. We have the setup depicted on the left. The device on the test is a router or a switch, which is fed power through a power meter. There's only one line showed here, but it could be two lines if you use two power supplies in parallel. That's not relevant. And then we have an orchestrator machine that, in our case, we use at the same time to collect the power measurements, configure the device, and send and receive traffic for the cases where we do need traffic. You do all those experiments, you compile the power model, and then you get, in this case, a text file that will show you all the parameters values for your given model. Right. So through this entire process, we finally establish a power model, which now we can finally try to compare and validate with the measurement data to see if the model is indeed able to predict what we're interested in. So here is, maybe, yeah, there we go. So here are some results on one specific model that was, so one specific router deployed in the switch network. What you can see is in red is the internal measurements that are being collected by the router itself. Blue is the external measurement that we take as a ground truth, and green is the predictions made by the model, established with the procedure I just explained. So we observe a couple of things. The first is that those lines, although there are some offset between the different lines, they seem to capture the same signal. Right? It's a bit difficult to see at the scale, but believe me, if you were to zoom in on the things, you observe the same weekly and daily patterns in the traffic and the dynamic power. And then we can see, I don't have a pointer here, but the main steps for links going down, being taken up and then back in, show on all three lines. So it appears that the model is somewhat able to capture what we're interested in, which is the fluctuation due to traffic and the change in interface states. However, there are some drops in the green lines that we don't yet see on the other, we don't see on the other blue and red curves, which are yet to be explained. I'll come back to this in a minute. Generally speaking, this power model appears to be reasonably able to capture the dimensions we're interested in. So let's go ahead and try to use that model to predict what would happen if we were to implement some leap slipping approach. So for that, as a use case, we used our own work, which I think I talked about last time, which is essentially an algorithm that tries to put links to sleep at a daily time scale. So you turn things off at night, and then you turn back up when you have your peak traffic. I don't want to get into the details of how it does it. It's not really relevant. The important takeaway is that in the simulation, we see that on the switch network, which is seriously underutilized, we could turn off about 30%, 1/3 of the links pretty much all the time. And now we could use our power model to really estimate how much that would save at the scale of the network. And the answer is almost nothing. Less than 1% of the total network power budget. Now, if I'm telling you that I can turn off 1/3 of the link and it saves less than 1% of the energy, the first intuition would be that the link budget is a very small portion of the total network budget. And that turns out that this is not true. This is not what's happening. What is happening is that in that particular case, when we turn off the links, things are actually not powered off. And that was actually already visible in the power models that we've established. So here are two examples. You can see on the slide the power for the transceiver in and up is the power cost that you see when you plug in the transceiver, and then when the IP link gets up. And you see that in this first case, for an electrical passive cable, you pay 40% of the power costs when you plug in already, even though the link is always down. And it's even worse when you start considering optical transceivers, which first draw 10 times as much power, but also, get powered full on as soon as they get plugged in, right? And it turns out that is exactly what was happening on the graph I showed before. By checking the logs, we could double check and confirm that on that day, one link was taken down for maintenance reasons, but the transceiver was still plugged in. And the model wrongly assumed that since we didn't see any traffic counters anymore, then there was nothing on this port. Except there was a transceiver, and it was still plugged in and still drawing power, which is why the blue and green and red line, don't deep, and the green line wrongfully deeped. The fact that we don't power off those transceivers is not necessary per se. There's no technical limitation to change that. And in fact, I will talk about people that are starting to address these problems at the end. It's a software problem and something that can be fixed and should be fixed. Right? Why is it the case today? I can only assume is because drivers and firmware and network operating system haven't been written with too much care about making those power optimizations. And we've been looking into proving that point by working with open operating systems like Sonic, so that we can tweak those drivers and really harvest those energy savings from turning things off. It's been a bit complicated to get those things running. If you have experience with this, it would be interesting to chat with you guys. So in this presentation so far, I presented how we can establish a power model that is appropriate to estimate those energy savings optimizations in a network. And I just showed like one example of how much it would hope to save. And I showed that as of today, it would not save much, but it's not really the optimization technique that is to blame, is more lower layers, hardware and software configurations. I want to close with some additional tidbits and things we've learned through the course of this project that are relevant for the working group. The first is that, as we expected, data sheets are not very useful to tell us really what's the actual power draw. We would expect those data sheets to give a fairly large overestimation, because that's kind of what those power numbers are meant to be used for. However, it was kind of surprising to see that in certain cases, we had devices that were drawing a lot more than what the datasheet was reporting, which is not supposed to happen. And those devices were not particularly highly loaded, right? So there's nothing special about those routers. But on those models, which happen to be from Cisco only because there's only Cisco hardware in the switch network, seems that datasheets are not even guaranteed to provide an overestimate on power. The other thing is that indeed, the power reported by the PSUs is not necessarily reliable. In the graph I showed before, the red curve was matching quite well what we were measuring. They were quite well the baseline. On other models, it's essentially pretty much a straight line with some dips here. And effectively, if you pay attention to the dip, we have a drop in the red curve exactly when we start to measure. And if you look at the detail, one of those power supplies, we unplugged, replugged, and all of a sudden it reported 7 watt less, while obviously nothing had changed in the middle. So it's like, yeah, you cannot really trust much of that. The sad thing is, until you measure, you don't know whether you can trust the internal measurements or not, right? So it's a bit of a problematic thing here. Another fun fact, or not so fun fact, is that sometimes you have huge power changes for reasons you would not expect a priori. So this is again a deployment graph, where on this day, around beginning of March 24, we saw a 10% increase in one router, and that turned out to be due to an OS upgrade. More specifically, during that upgrade, there was a change in the control loop for the temperature management, and the fan started like going full blast. Well, was not much going on in the router per se, and that got reverted eventually by Cisco in the future release. And finally, as I mentioned, this is not directly from our own work, but through this project, we learned about other initiatives by different vendors to improve energy efficiency of their routers. And Juniper has been doing a lot of work in this area recently. They found out that in some of the routers, internally, the SerDes line would remain up all the time, would remain powered up, even though the interface were unused. And they've noticed this, and they've provided fixes for this problem. So in some of their machines, you have now this new unused keyword that you can put into the interface configuration to effectively power off the SerDes if there's nothing plugged in that port ever. And they show in those references that it actually saves a significant amount of power on those machines. Right, so this wraps up this presentation. There was not only work from myself, obviously, lots of people involved that you can list here. One thing I wanted to point out before closing is that through this project, we've also, so we've collected a lot of power-related data. We made all this power information available in a public database we call the Network Power Zoo, from which you can go, browse the information that is there, request data downloads, and we've built a system to be easily extendable to collect other input data sources. So for, sorry, for the people in the room that manage network, if you routinely collect power measurement from your infrastructure, would be very interesting in including and folding this data into the database. And I'll close there and welcome any questions or reaction from your side. Thank you.
Okay, thank you very much for being well on time. And
thank you for a great talk.
yeah, so Luis.
Hi, Romain. This is Luis from Telefonica. Very good work. Just a question for clarification. All the routers that you have characterized are monolithic, right? So not modular, because in your model.
Yes, correct.
Okay.
Correct. So far, we only looked at fixed chassis routers for convenience reason mostly, just because that's what we had available. And we haven't entered the direction of the modular chassis where it gets a bit more complicated, because I think to estimate or to model the line card, it would be kind of the same thing. But then you also have like additional components like the fabric cards and so on that would need their own specific kind of modeling approaches. And we haven't looked at this so far.
Okay, thank you.
Okay, Jainam.
Hey, Omain, thanks for the presentation. So I had one question. Have you tried testing the things with an LPO optic? I mean, linear pluggable optic, which has been out in the market since some time. I mean, the DSP out of those optics have been taken away, so it does draw significantly less amount of power.
So I'm not, you said linear
pluggable optics. Linear pluggable optics, LPO.
No, it's not something I'm familiar with. So we most likely didn't test with that. We essentially tested with everything people were kind enough to lend us. so electrical transceivers and some classic optical ones, SR and LRs primarily, LR, LR4, some extended range as well.
Okay.
But yeah, I would not pretend having an extensive knowledge of the transceiver space. What seemed like in all the transceivers we looked at, what it seemed to be the case is that indeed, as it kind of makes sense from a physics point of view, when you have an optical transceiver, what consumes energy is the laser, but then the modulation of the signal on the laser is essentially transparent power-wise. Yeah. So it kind of makes sense that the power draw of a transceiver is a constant value. So we haven't digged into that much, and we've used on the few transceivers we could measure. We observed that the power demand was matching fairly well what the datasheets were saying. So we flied under the assumption that we could trust the datasheet value as being the constant power for the transceivers.
Makes sense. Yeah. I mean, yeah, it would be a good thing. So something about the LPO. LPO has, I mean, it's as, I mean, not same, but it comes into the SR and the FR ranges. I need to confirm, but essentially the DSP, digital signal processor, has just been taken away from the transceiver. So that unit
is where?
Sorry, I think it is offloaded into the chassis. Again, I'm not an expert, but I need to see where things happen if a thing is taken away from the optic. But the unit itself takes way less power since a component has been taken away.
Yeah.
Yeah. Okay. I mean, thanks a lot for doing this. It was fun looking at the numbers.
Yeah, thanks.
Thank you.
Okay. I see nobody else in queue, and we're right on top of the hour. So that's wonderful. Thank you very much.
You're welcome.
And
I
I'll
think
hand
I
over.
can do next deck. Let's see what happens if that do that.
It's okay. You don't need to do anything anymore, I think.
All right.
Yeah.
All right. Thank you, everyone. It's end of the afternoon here, so I have to go get my kids. Unfortunately, I cannot stick around for too much, but I'll check the recordings.
Have a good evening.
Thank you all. Bye-bye.
Bye. Thanks. Okay, with that, we hand over to Carlos.
Thank you very much. And Romain, thank you very much for a great presentation. So Jainam and myself are going to be sharing about this draft and this specific approach that we have on behalf of the larger team, which includes Ron, Bonica, and Michael Welch as well. Title is ICMP extensions for environmental information. So what is the motivation? At the net of it, you're gonna see that the approach that we have is to include specific environmental information as part of extended ICMP messages. Why do we want to do this? What do we want to achieve? First of all, networking devices are actually capturing, measuring, and exposing by way of their internal APIs a lot of additional environmental information. So power draw, energy use, temperature, a number of other metrics are available within a device. Now, from an operational standpoint, ping and trace route and additional tools like probe, ICMP-based tools are fairly ubiquitous when it gets to debugging, troubleshooting, and operating networks. At the whether it's at the CLI level, issuing commands, or from any type of NMS, there's universally available ping, trace route implementations and commands that actually make use of exercising that network. So many years ago, and starting with MPLS, with RFC 4884, we actually had significant success in having an ICMP-based multi-part message, which can actually carry a number of additional sets of information. Checking right before making this presentation, that RFC has 35 data tracker references. That means references from either existing RFCs or from internet drafts. And of course, and more importantly, many implementations, whether it's actually vendor implementations, starting with Cisco Juniper. I work at Cisco, then tap and work at Cisco, and Ron Bonica at Juniper at the time of that RFC, but also a lot of open source implementations. What is the objective? Visibility on environmental information in a way that is accessible to operators in the most accessible way, and something that can be used in a transactional matter, meaning I log into a network and I issue a command from the CLI, or in any type of automation, as many operational automations are based on probes of ICMPs. Those can be leveraged to also carry environmental information. There's a copy of the abstract right there that you can see, and the core of it is ICMP messages, environmentally sustainable information that gets added. So, we're going to dive much deeper into the how, but at the highest level, that is the objective of this work. And one question that that we hear specifically, we heard this from an AD. How does doing this, how this conveying information in ICMP would really unlock new usages for operators? There's YAM, there's many other retrieval methods. So I'm not going to read every single bullet point there, but the idea is that we have data plane correlation. This is not a collection mechanism. It's not a collector, but really is correlating with data plane activities as they are done using ICMPs. Visibility from an operational standpoint at the lowest common layer, meaning if you cannot get access to issuing ICMPs to do a couple of pings or trace routes, there's no simpler tool that you can get yourself access to. A research utility that is cross-domain, built on extensibility that is proving, and of course, this doesn't preclude any other solution to retrieve environmental information using more complex or rich methods, such as YANG, for example. So let's talk a little bit about the specifics on the how. And Jaina, I'm going to test your mic and see if you want to pick up from this slide.
Yes, sure. Thanks, Carlos. Hey, everyone. Thanks a lot for joining. I hope you're having a good time till this point. So, continuing to what Carlos just mentioned, is that what we have done is that we have kept for RFC 4884 and 8335 as our base. And what we're essentially doing is that choosing specific ICMP messages to use them to be able to add the extension that we have defined in this particular draft. So, and one of them that we're going to use is the extended echo reply. So we have a proof of concept as well. So we'll be talking about that in future slides. Next slide, please. Okay, so what we have done till now. So we have been able to define certain numbers of information elements, including, let's say, node power draw, the power draw of the entire chassis, its throughput, some EERC information, some component level information, like component level power draw, component level throughput. Currently they have been defined in two variants, the short and wide. The short is 32-bit, wide is 64. But again, we were able to get some feedback from the wider wider group, is that having two options is good, but it may be difficult to implement. So we have decided to just deprecate the 32-bit and just have the 64-bit going onwards, so that it's future ready in the first place and it becomes easier to implement. Next slide, please. So talking about proof of concepts, we have currently two proof of concepts. One is a BPF and C-based implementation done by William Hawkins. Thanks a lot, William, for that. And the second one is that it's a Python-based, it's used Scapy, the Python library, also uses the extended echo response to fetch the information, and we will be, actually I had a chance to work on this, so we'll be looking into this today. Next slide, please. Okay, so it's essentially two scripts, a sender and a receiver. Sender will send the ICMP extended echo request, and the receiver will just respond with an extended echo reply. And we have two flags, the probe and the green. Green flag is the one that is related to this draft. Probe flag is the one which corresponds to RFC 8335, where extended echo reply was defined in the first place. So essentially with this, when the sender sends the extended echo request, the receiver, if it has the flags, it will append the respective message into that response. So essentially the reason behind doing this is to show off that, one, it is backwards compatible. Number two, if a receiver is not configured with green extensions, it can simply respond with the extended echo reply without appending our extension. Next slide, please. So this is the ICMP request, just this simple good old ICMP message type 42. which the sender sends. Next slide, please. And this is where the reply will come into play. So what we are doing is we are appending the first C type that we have defined, the node power draw, 180.
Excuse
Next
me,
slide.
Jainam, we only have 1 minute left and a lot
Yes.
of slides to go. So
Yeah. Next slide, please. So this is the response, and we can see that the response has been appended. Wireshark doesn't know how to read through it, but it can be easy to do. But we can see that along with the extended echo response, we have the new extension appended as well. Next slide, please. And here what we have done is that we have played around with the flags. When we set the green flag as 0, we just will get the simple extended echo response. Next slide, please. And here we have taken an experimental liberty to show off that when we set the probe flag to 0, we can use the extended echo reply to send the extension that we have defined here or any other information in the future. So this is one way to show off that extended echo response can also be extended and to not only use interface identification object. Next slide, please. So we have a running code and we have a POC as well. And we would request the wider team to see if you have any suggestions for any effective approach for standardization or any other suggestions. So that was all, I think, finished almost on time.
okay, great. Yes, questions, comments. The question about how to standardize, I think, is a question not just to us here, but to the room. I mean, we're not doing standards in the IETF, so.
For sure, it's a broader question, and even though we're short on time today, we're open to continue the conversation. This is an invitation to continue the conversation offline on this draft. Should anyone be curious, interested, or have suggestions or observations for us?
Yeah, Dirk.
Yeah, hi, Dirk Kutscher. So it's great to see that practical work coming along. So I think the question is, what's the most valuable activity for this group? And so I think doing more experiments, learning from that, and then maybe in the future you can make some suggestions. So what could make sense for standardization? So I think that's the way we typically work.
I appreciate that. That's awesome. So challenge accepted to play a little bit more with some of these tools, for sure. Michael, Eve, thank you very much.
It's all right.
Thank you very much. Actually, I have a quick question, which is, have you thought about maybe a hackathon in some context, whether that's a workshop or an IETF or some place that could actually send you back some interesting information? So maybe that's something to think about as well. What would be an interesting test bed for this?
I love that idea. We have thought about it. It depends on physical presence on the day of the hackathon to make something more effective. But I think the maturity of this is one that would actually really benefit from that broader, finger on keyboard and real test doing a hackathon over internet and things like that. So, Eve, great suggestion.
Yeah, I mean, a hackathon would be a good thing. I mean, I did not have a lot of time to play around with the POC that we just built. So it is in bare minimums. So yes, a hackathon would be a good thing to get more people on it and to get more ideas.
But I think even where I was going with this is what kind of environment might actually return some interesting information, particularly given the previous talk that, not everything is behaving as we expect, and not everything is really measuring or reporting things as expected. So anyway, I think it's more of a thought question, and we'd love to hear, how would you design an interesting experiment that maybe could even accelerate hardware manufacturers, developers, owners, operators, to participate in something like this? What are the kinds of things they want back that they're not getting or that they see as inaccurate? Anyway, thought experiment.
Okay.
Thank you so much again. Great talk. And it's great to see these the maturity of these IDs.
All right.
Thanks everyone.
Which brings us to Jan. Let me see. Slides. This. Not upload, no. Share.
Very good, thank you.
Can give you the control. So you should be good. You should be in control of the slides, and I'll hand over with this.
Okay, great, thanks. Yeah, I wanted to talk about the Carbon Accounting Alliance, what it is, how to connect with it, and what to do with it. And this is based on an event that took place a couple of weeks ago. I don't seem to have the controls yet.
I think you. Oh, I'll do it again. Maybe I didn't.
You got the slides control. Now I have. Good, thanks.
Okay.
Yeah. So the Carbon Accounting Alliance, often abbreviated CAA, it's an association, non-profit association based in London, and there's more than 800 companies of all sizes that have joined them now from a large part of the world. And they say that they bring together carbon accounting professionals who measure and report carbon emissions, which includes software companies, consultancies, auditors, in-house sustainability managers, standards bodies, and independent professionals. And in my world, this sounds like me or us. So I thought this was interesting and took a closer look at them. And they have something called working groups inside this CAA organization. And you can see some of the groups here. Some of them are thematic and some are regional. And I highlighted a few at the bottom there that I think might be especially interesting to people like us. And I, for one, is trying to enter this software interoperability working group, both because I want to work with carbon accounting from our point of view. I want to have somebody to deliver our data to that understands what we are doing, and we have to understand what they expect from something that is measuring energy and emissions. And also because they are building all sorts of, or they are building standards around that for carbon accountants. And they have fairly low understanding of how software works. So we can actually step in there and help them get things done. Yeah, so on the 7th of October, a couple of weeks ago, there was the first event that Carbon Accounting Conference, that the Carbon Accounting Alliance arranged. So that conference was taking place in London and online. And I decided I wanted to participate in that, so I joined them remotely. And there was, I've met carbon accountant people from time to time, discuss with them how they see the world and so on. But this was a kind of different experience when having hundreds of them in the same room and listening to what sort of things they talk about when they want to develop Scope 2 and Scope 3 and the ways that you do accounting, and hearing from the GHG protocol directors and SBTI engagement managers and so on. So that was, it felt like a very good contact surface for an organization like us, both from the IETF and IETF point of view, where we are doing technical standards. We need these folks to know what we are doing, because if we don't make them understand or care what we do, we can just as well stop, because here's where it needs to land. I picked up a few of the things that they talked about. They talked about spend-based, activity-based, market-based, and location-based measurements, for example, where spend-based is the method where they take a company's spendings in dollars or yens or euros and try to apply an emission factor, saying that, oh, this sort of spending, you're buying data center hosting or something like that has an emission factor of so many CO2 units per dollar or per euro. And then they apply that. And these consultancy organizations, they have whole libraries of emission factors for different types of things that you can buy. And in many cases, these emission factors are even a secret sauce for a particular company. They guard them closely, what they have computed. So it makes it very difficult for others to verify or work with these computation numbers that they came up with when they are doing the assessments. So CAA is starting a new project called Carbon Commons. It's a sort of generally available common library of emission factors for spend-based accounting. So they call this a not-for-profit data set. So everybody should be able to get it, but not entirely for free. There's some management costs for maintaining this data, and they would like to have those costs paid. So you can't get it for free. But the development cost of this library is not, that is for free. So they don't charge for that part. The contrast to spend-based accounting is activity-based accounting. Then you are trying to analyze each activity and deriving numbers for that. That's a lot more work, but it's also much more accurate, maybe. And a quote from the floor there is, "We need both, but how do we combine them? Because it's difficult to count in different ways and try to add up the numbers and get something meaningful." Another distinction they talked a lot about was this market versus location-based accounting, and this is particularly relevant for scope 2, meaning mostly when you're buying energy, usually electricity. Should you, when you're buying your electricity, look at the energy mix based on what you are paying for? Let's say I'm a company in London and I'm buying electricity with only solar power. So I'm paying a premium to get solar power. So should they be accounting this as I'm very green and clean? Or should it instead, with the location-based accounting, look at the energy mix that's in the grid at that point, in that geographic point, and say that everybody in here in London will have this mix because that's what's in the grid here. But then that will not incentivize people to buy greener energy, for example. So there's pros and cons with each of these approaches, and all of them are used. Yeah, and another few comments I picked out at the conference. So one of the interesting facts is that a lot of countries are writing legislation that are including references to the Greenhouse Gas Protocol, GHG. But actually, if you look at GHG, that is a collection of information that is created by a specific organization called World Resources Institute, WRI. And it's basically unheard of in legal circles that you are writing laws that depend on external data. The laws have to be self-complete, basically. But here, a large part of these rules are referring to data that is coming from a US-based non-profit organization. It's kind of unusual. Somebody said that, yeah, we need to do CO2 accounting in a way that's compatible with how governments are doing it. Scope 2 is broken. Somebody said Scope 3 is broken because you can never do Scope 3 calculations properly unless everybody else is also doing that, and it's going to take some time. We need consistent system boundaries so that you count all the emissions within the boundary and none of the emissions outside the boundary. And transparency in these calculations is critical. So you need to have traceability, verifiability, and trustability, and they all depend completely on this transparency. So whatever we do when we are coming up with systems and principles for doing CO2 accounting, transparency is key. If anybody would be interested to join this CAA, that is possible. It's an open platform and anybody is free to apply and join. You obviously have to state some sort of reason why you want to join this group. But I was able to join at least. It was not hard. It took a few days, but it's okay. It's not difficult, not a lot of questions, and it's easy to fill in this. And I joined as representing my own little company, but one of the questions I might raise here is, should we send a representative here from IETF or IETF to this organization as some sort of liaison, or somebody who has the responsibility to communicate in some way or something? And I'll just note that on November 18, the next meeting of the Software Interop group, and I will try to join them there. Now I have 35 seconds left. Any comments or questions?
I mean, that is excluding the 5 minutes that we actually have Slack for discussion.
Ah,
so,
right. Okay, so
people should be discussing and raising questions if they have any, like if there's anything to discuss. Right, we have Marisol.
Hi, thank you, Jan, for this and also for all the sharing on the mailer. I have a question because you talk about the scope 2, 3. What about the scope 4 that is, well, I think is more and more known, but is more on the avoiding emissions, where it could be as well somehow accounted to, if you reduce emissions, you are doing that net zero effect, right? And I think it's as well as relevant as accounting for the emissions that you are putting, or even more because you are pricing that. Is there anything discussed so far?
I think that was discussed a little bit, but it was not a major theme. And I think a lot of people are also associating this sort of counting with, well, it's hairy, and you can go very wrong. Like, I didn't fly today, so that's an avoided emission. So should I count that as something? It's difficult, but it's worth taking it up with these professionals. This is the right place to discuss such things, I think, the CAA, I mean.
Right, thank you.
Yeah, Dirk.
Hey, Dirk Kutscher. Yeah, thanks, Jan. On the question, should someone join as IETF or IETF representative? We can't really do this. So if someone joins, then it has to be, in their own capacity or their own company.
Okay. Anything more? Anybody?
Yep, Adrian here. So maybe one last question, Jan. I saw that there is a working group dedicated to regulation or regulatory monitoring, but is there any work group or talks regarding standards right now? So are they aware of the job that we are doing here, or the job that it's being done on other SDOs?
I mean, they have definitely some monitoring of different organizations and things like this. But I don't think that they, I mean, I talked to some of the people in the software interoperability group at that conference. So they were, oh, cool. But they had, of course, never heard about IETF or IRTF at all. So, and they had very little insight into software space in general. So
okay,
we need to connect with these people if we want our standards to be used, I think, because these are the people that are actually doing the evaluations of all the companies around the world.
Thanks.
Okay.
Can you give us a sense, Jan, of what are they doing presently in the software working group? What kinds of things are either developed already or getting discussed? Some of the database stuff sounds fascinating, actually.
Yeah, I was there was a break at the end of the conference. There was a couple of hours breakout for each of these groups. So I was in the software interoperability group, and I thought the discussion there was both very interesting and in some areas quite naive. So I wanted to contribute my understanding of how software works to that group. But they definitely talked about there are some existing big reporting platforms that are being used, but it's somebody at the conference said, yeah, we are saving the world by emailing Excel sheets. So that's the sort of state of this area.
Yes, in fact, one of the things I've often thought could be a useful contribution from IETF is Yang models of the data models that live behind these reporting data structures. They're essentially data structures, but they're now represented in Excel spreadsheets. They're not represented in things that you could put into a communication protocol. And as a consequence, everybody writes their own data structure or their own data model. And so that might be a quite interesting fit for something like the IETF.
Yes, it's definitely interesting. And some of the people that are on this is, for example, the EU. They have defined large data structures with basically lots and lots of boxes that you have to fill in when you are doing reporting, ESRS reporting and things like that. So it's we are not first here, but maybe we can bring something interesting to the mix and more concrete tooling.
Okay. All right. Adrian, is that you asking something more, or is that you already presenting, which will be fitting?
Presenting.
Okay. Then I will thank Jan and try to share.
Yeah, thank you very much, Jan. Super interesting.
Okay. You should get slide control now.
Yes, thanks a lot. So
okay.
hi everyone.
The timer is only the presentation, so don't be confused.
Okay, perfect. Thanks. So yeah, again, hi everyone. This is Adrián Gallego. I can also go for Adrian. It's fine with me. So I'm a 5G architect on Deutsche Telekom, and I will present in the Path Energy Traffic Radio API, aka Petra, but the augmented version on behalf of the rest of the authors. So we have Alberto, Luis, Marisol, and Jan. First of all, I would like to give a small introduction, a little bit of context of where are we coming from, because we also are developing the work in the IETF Green Working Group. And back then, I was not part of the authors, but this all started when the PAN-RG was in place, and we have been presented the idea around on several IETF venues. My colleague, Luis, will also be presenting the Petra version on the Green Working Group this afternoon. So good luck with that one, Luis. And yeah, the original motivation came because back then there was no way of gaining visibility on what's the energy consumption in a given network path. So we said, what if we are able to develop an API that exactly does that and provides or returns the energy efficiency or the power consumption for that specific path? Of course, if we look into the right-hand side, if we want to go from a point A to a point B in the network, depending on the devices that we have, the network architecture, and so on, most probably multiple paths will be available, and each of them will have a different energy consumption. So therefore, I just want to highlight that the Petra API stands between the final consumer, that can be an external consumer, such as orchestrators or customers, and internal consumers, such as operators, admins, and so on, and the network controller. So basically, Petra is just forwarding the information. It's not the one in charge of talking with each device on the network path and retrieving it. That's in charge of the network controller. So this is the context. This is coming from our work in the IETF Green Work Group. Now let's dive in a little bit on the augmented version. So far, the problem that we have seen is that the Green Work Group is focused or highly focused, as their charter describes, on energy efficiency. So whenever we want to retrieve metrics with this API, we are just focused on this power consumption or energy efficiency. But if we wanted to bring in a wider sustainable scope, then we were a little bit limited. So that's why we took this step further and brought this topic also into this RG. So basically right now, the motivation for this Petra augmented or Petra extended version is that we saw some benefit on trying to focus on a broader scope and trying to address more energy attributes just beyond power consumption. So as I will explain in a further slide, we have introduced new energy or sustainably related metrics. And we have also extended some of the use cases that we described in the IETF green version. Just small reference here to the green energy management framework. So they have defined this functional architecture. Just want to mention that our API could be allocated on this G interface, the so-called API service interface, which, as you can see, receives information from the network domain level and the controller. Okay. Then going back again to the Petra augmented, let's see what is new here. So basically, besides running the updates that we have done with our previous work, we have also added these additional attributes. We have a dedicated slide on that one. We have also included a small clarification regarding the recursive usage of the API on double counting. So basically, double counting stands for if you're using the API recursively, a given network segment, you might be counting the energy twice, thrice, or more times. So basically what we clarified there is that the API would not take care itself of avoiding that double counting, but the entity using the API should be the one in charge of taking care of that. Of course, we have also modified the Jank model and the Jank model definition accordingly to these new energy attributes. And as mentioned, we've extended the SD1 use case and added a new one. So the extension of the SD1 use case basically covers now 5G slice orchestrators and multi-domain orchestrators. Before that, it was just focused on SD-WAN orchestrators, which basically now opens the door to defining 5G slices based on the energy attributes that we are returning with this API. And a little bit linked to that, and I think it's this one is interesting from the MNO or from the service provider point of view. We open the door to defining the so-called green SLAs. So let's say that the final user or customers want to fulfill the 2030 agenda just by reducing the carbon footprint, and they want to ensure that all their traffic, or maybe a percentage of the traffic, is going to be a network path that only uses low carbon footprint devices, or where always the energy is coming from renewables. That could be a state on this kind of use case using our API. And finally, here we can see a list of the new energy attributes. So the two first ones are coming from the Petra, the original version, and the ones highlighted in bold are the new ones. Of course, I think I don't need to explain the energy mix, but let's focus on the rest of them. So the greenness degree, it's a bit similar to the energy mix, but it's highly focused on renewables. And we have defined it here as a different metric or a different attribute because we wanted to somehow quantify how sustainable a given network path is. And for that, we defined the sustainable score, which is linked to both the greenness degree in terms of how much renewable energy is being used, and watts per gigabit on the different network segments of a given network path. We've also defined the power usage effectiveness, which we might think that it might come useful for infrastructure providers or data center owners, just to compare the total energy consumption in a given facility with the energy consumed on a given path, so that with that you can know how much energy efficient, sustainable, or green. I don't really want to use the word green here to avoid any misreferences. It's a network path. We defined also the transmission loss. We are thinking about changing the name of here because it's a little bit misleading to energy transmission loss, which just gives an information on how much energy it's potentially lost or is being lost on a given path. This would help know more optimal paths in terms of energy and also even to detect failures. And finally, as we need to maybe compare, it's always good to have the idle energy draw on a given path to compare it with full throughput or mid throughput. So this would be the whole new list. And well, regarding next steps, basically we will really be glad of gathering and incorporating new RG feedback. We're also willing to adapt the wording a little bit because, as you have seen, it's a little bit difficult to reference the Petra IETF version, Petra augmented version. Also, we are trying to get rid of any green words just to avoid any misleading references to the IETF working group. We have been discussing these a lot around, and we have also received some comments regarding the third point. So right now we are using source and destination IPs, which means that the paths are defined by layer 3. So we are willing to extend this one a little bit, just to make it more general. Of course, we also and already discussing some of the received suggestions on the sustain email list, especially those to David Oren, which basically reflected on how to demonstrate that the answers given or returned by the API are stable and over a certain period of time. So let's say that we are getting the energy mix, that answer that we received, how stable is going to be over a certain period of time. So how much is going to use X% on biomass, etc., etc. Also, we will be really happy to explore new incentive scenarios or use cases. And finally, we would like to keep the link to the Green Working Group. And just to end up, I always like to end with a fun point. This was supposed to be a gift from Star Wars when Obi-Wan Kenobi gets rid of the hood and says, "Hello there." So as you've seen, the name is not really the best one right now. So we have been looking to a new name, to find a new name. This is so far what we have come up with. So again, we will be really happy to get some feedback. And yeah, I mean, it could even be open for a vote and see which one is preferred by the group. Yep, just in time. That's all.
Great job keeping the time. Thank you very much. So, questions, comments, suggestions, ideas?
Dirk.
Yeah, thanks. So I haven't followed this very closely, but one question: do you have to think about like certifying this information? I mean, can I not put in anything myself, and who knows whether it's actually accurate or not?
So far we are trusting a little bit. We are dependent there on. Let me move to this slide. As mentioned, we have a tight dependency or a tight coupling with the Green Energy Management Framework. And therefore, we think that the energy which is being returned by our API is coming either from the network domain level or either from a network controller. So the certification of the information should come from either one of those entities.
So,
yeah,
so Jukka Manner, not Jari Arkko this time. Can you go to slide 8?
Yep. This one?
8, not 9.
Sorry, yeah. It's on the slide deck here. Yeah, yep. There you go.
Still one back. You had this, the list of.
Yep, yeah. Here we are.
Okay, so you have these attributes: energy mix, greenness. Just a comment here that greenness in this is equals renewable. Now, I always try to remind people that if you look at the life cycle emissions of different energy sources, and for example, there is a very good, United Nations Economic Commission for Europe analyzing the emissions from different energy sources, and the number one by far is nuclear. Not renewables. So in that sense, when you are looking at these attributes, then I would rather see probably something in the carbon emission of the electric source. Okay, you have the carbon emissions generated. Okay, so the carbon intensity is probably, or something like that is much more relevant than, for example, greenness degree. Because, for example, if you take offshore wind turbines, then they are many-fold more, create more emissions than, for example, nuclear. So I might, consider to, revisit this, greenness and, whether green is renewable or whether it's in general the emissions of the energy source. That's just a comment.
Okay, so then your suggestion would be more to focus on the emissions to define the greenness degree instead of just focusing on renewables, because the source of the energy might come.
Yeah, because it's a fact that with, of course, nuclear is not a very popular source of energy, but in the fact is that if you take the full life cycle emissions, then nuclear is the greenest source humans can create today. So, and it's available 24/7 and so forth. So it's just a comment that maybe the greenness and renewable sources, yeah, it's nice, but at the end, what counts is the emissions, whether it's the operational emissions or building, running, decommission the plant, then it's a bit different.
Yeah, thanks for the comment. So again, just to clarify, the idea here is to have some sort of scoring on how sustainable and sustainable from the broader view it's a given network path. So we need some kind of index. It could be dependent on the emissions. It could be dependent on whatever we decide or vote here in the RG. But we would like to quantify, to have a quantified metric for that. So that's why either we use the greenness degree or other, but we would like to keep the sustainability score. So yeah, that's up to discussion. Thanks.
All right.
Any other questions? Thank you so much. Very interesting developments, and clearly more discussion needed in some regards, but it's great to see that you're focused on this. Thank you for your talk. And I had a suggestion of the title being Patronus as a shout out to Harry Potter, but I know.
Nice one.
Okay.
Okay. Thank you very much indeed. That brings us to Jukka already. I have a new theory about this. I don't think I have a problem with Finnish names. I think what happened is I took the agenda from last time, and Jari was actually the last presenter last time.
You want to exchange, Jari?
I'll have to give the slide tracker the slide control. So
Do you see the timer
now
there?
you should be.
You can try to give a shortened version of your presentation.
It was just that you were the last
Just
one.
buy
Last.
more 5G.
Sorry,
you were.
What was the? Sorry, I missed. What was the? 5G is the solution, or 6G?
Just get more 5G. It'll be fine.
Isn't 6G nowadays the, that everybody should be getting, or 7G?
As long as you guys agree, I mean, it's okay.
Okay. Okay. So this is a presentation. I used the full slides of a student's paper that was presented a couple of months ago at PMRC, and it's really about understanding what happens when you are shutting down old technologies. I mean, typically you add, after 2G, we added 3G and then 4G and 5G. And, every decade there is a new technology coming. And if you look at, industry reports of how many tens of percents to save on shutting down 3G, it's just hilarious if you look at industry reports and stuff. So we wanted to really see what is happening. And I mean, 3G nowadays is mostly used by IoT networks and IoT devices. So often, at least in Western countries, it's for embedded systems mostly. And one thing to note is that it's not like you have separate 2G hardware, 3G hardware, 4G hardware, 5G hardware, 6G hardware, but you definitely modern devices are multi-radio access technologies. So RAT means radio access technologies. So same hardware runs different radio technologies. So what we had actually, we looked at real operational data. So this is not simulations. This is not emulation. This is there's a typo. It's actually 1,500 base stations in Finland where Telia shut down 3G, and we were looking at what is happening really in the network when 3G is shut down. And 3G in this case refers to the 900 megahertz band, which was used in Finland in this 3G. And we did some theoretical evaluations, but effectively the rest of the talk is just to show what happens really on the base stations when 3G disappears, and whether there is a huge savings in energy or maybe not. So this is the first of I think three slides of numbers. So this is what happens. So you see the red line when 3G 900 megahertz was shut down from these base stations, these 1,500 base stations across Finland. And then the blue line is when the 900 megahertz was given to 4G. So of course it's not it's not disappearing, but we are reusing the 900 in the more modern technology. So, and this is for basically one cell sector, the radio access, the radio module, which is running these 2G, 3G, 4G technologies. So before the sunset, the average of all these 1,500 base stations was like 435 watts, and when 3G disappeared, we saved like 20 watts, not 50% or 30%. That was in some of these industry analyses, so which is kind of maybe a bit hilarious. But then when you refarm the same frequency to 4G, then you get back to the same original energy consumption level. So the savings are zero in a sense. So then we were looking at also on the traffic level that what is happening, and can we understand what is happening on different levels. So here is another graph where we should see the same red spot, or the red line, which is when the 3G 900 megahertz was closed, and then the blue, the moment when it was refarmed for 4G. And you see that when if you look at the black line at the bottom, then that's 2G. So some of that 3G load actually went on the 2G network, and you can see it actually spike on the 2G load. But then you can see the 2G, the black line going down. So people realized, because these 2G, 3G devices often are these, embedded, maybe, video cameras somewhere on your summer cottage or things like that. Then people started exchanging these old hardware to newer ones. So actually, when they realized that, okay, therefore some video picture stream from that, embedded device started to be bad, then they actually bought new hardware. So that's why the load on the 2G network went up, but then it started gradually diminishing, and you can see at the end of this graph, the black line is pretty much the same as it was before. So essentially 3G devices that were 3G only, then either jump to 2G, or people exchange them and they join the 4G network. If you look at that, so these are the sub-gigahertz bands. So you can see those different bands, and uplink and downlink throughput, and effectively you see no changes in the traffic on these, because the amount of traffic on the 3G network is so small that it doesn't really have impact all these other 4G and 5G 700, 800, 900 frequencies at all. So the change in the traffic is microscopic. We also looked at the more closely the 800 and 900 megahertz on 4G. So what happened before and after? So in this graph, the purple cyan is the 800 megahertz download, for example, downlink traffic, so megabytes per day in all of these graphs. That's how in mobile context we measure traffic. Then there's effectively no change. And there is some traffic then that came to the 900 megahertz, but effectively, if you look at the scale of the y-axis, then it's actually a small increase on the 900 megahertz downlink and uplink traffic. And then we also looked at the mid-band, because people get these new devices and you get this 3G traffic goes away, then did it affect the 1800, 2600, even the 5G traffic? And effectively nothing happened there. So there's so small amount of data that was any more left in the 3G network, at least in Finland, then in practice no change in the traffic. So in conclusion, this says, sunsetting 3G saves 60 watts of power. So it's a question that is 20 watts per sector. And when you have 3 sectors on a base station, that's 3 times 20 watts. So basically would have saved 60 watts of power consumption. But then since it was refarmed on the 4G, then the effect is 0. So it doesn't change save anything. The main benefit is of course the increased capacity that 4G gives on the same frequency band than what 3G was giving. So and the last bullet here says that some of the 3G traffic actually disappeared for good because you had these devices which were 3G only, and then they stopped working and people had to switch those. So maybe that's the biggest impact if you think about it, that some devices lose connectivity and then you forces people to upgrade them. Of course, let's say my car is a good example. It only has 3G, so my car didn't survive that, so it's now stuck on 2G. But I can still remotely start the warming system, so that works. But of course, you can't change embedded devices necessarily like cars and stuff and add 4G if it wasn't there already. But that's it. So final in summary, 3G doesn't save anything. Shutting down 3G didn't save anything from real data. Any questions, comments?
Yeah, we have
For
Eve.
me or Jari?
Hi. Yeah. Thanks for having a sense of humor about that. At least we understand where that came from. I'd say cut and paste, but in any case, thank you for this talk. It got me outside my comfort zone of thinking about the radio access network and operationally sort of what the impact is of that last, the connectivity of all of our mobile devices and so forth. But have you thought at all about the embodied carbon of these technologies? I remember reading somewhere that some of the biggest impact is from the trenching for these locations of the radio towers. And so the reuse of them could be quite impactful. Anyway, so I wondered if you've gone off in that direction at all.
Currently, the same hardware runs 2G, 3G, 4G. So basically, shutting down 3G doesn't introduce any new hardware and actually doesn't take out any hardware because you have the same hardware at the end. It might be that in some countries you still have physical 3G boxes from 10 years ago or 15 years ago, and then if you shut those down, then you might save something. But since you are refarming, the refarming means that you are not introducing new hardware, then I think the embedded carbon as such doesn't change at all.
Right. So I was thinking that by reusing the places, the locations for where the hardware is placed is a savings. But then if you need more towers or sites, that's where the embodied carbon, as opposed to the operational carbon, might be.
Yeah, but you're basically it's the sites are already there. It's just that you change kind of the radio technology, which is using the 900 megahertz. So then it's a total kind of different discussion that if you need new cell sites to be built, then that's not done from kind of the 3G kind of perspective, but it's more of a general coverage planning. So it's a different kind of question that if you build new sites, then how much embedded carbon that creates. And of course, that's big.
Thank you.
Thanks, Jukka. Just a thought. So from my memory of the LTE standardization, so LTE had quite a few elaborate features on energy saving, like self-organized networking, switching off, things like that. Do you happen to know whether any of this is actually used these days?
Yeah, it's used and it's being studied and it's being reported by my students as we speak. So we actually just finished. I need to review the last comments, and we are submitting a paper where we are looking at the potential of turning using machine learning to kind of turn off cell sites. And then we are looking currently with MIMO muting and all sorts of radio optimizations in another work currently all done with Telia and Nokia collaboration, so that we get actually in those. So you look at really what you can do with 4G, which do affect, and then also what is actually the quality of experience impact. Because if you shut down capacity, you shut down coverage, then you are kind of effectively impacting the users. So we're also matching that, if you have less resources, you have less capacity, and, kind of your quality of experience or quality of service goes down. So we are trying to map also that to shutting down, these fancy features in terms of saving energy. So that's actually ongoing work.
Yeah, okay, cool. Looking forward to the outcome. Thanks.
Yep.
Yeah,
That's
we
all?
have no. We have Jari in the queue. Maybe he's just trying to make another joke, or maybe he has a real question.
5G?
Jariak. So I clearly should not be making any more jokes, but I had a question about one of your slides mentioned that for each new generation, there's a tendency to have more downlink traffic. I was wondering if you could expand a little bit on what did you mean by that? Did you mean that there's a general trend in internet traffic or traffic over these networks, or that it's somehow connected to the changing of 3G to 4G?
Of course, there's two things. Of course, new technologies bring new capacity, so it increases the available resources. And as such, if that's what you mean, that of course, when we have a certain kind of, let's say, natural limit on for example, people's data usage. There's a natural limit on how much you can consume in a day. And of course, now we are still having 2G, 3G there. 4G mostly satisfies the need, but we've seen in 5G that the capacities are so huge already that wonder that.
Okay, but there is this general tendency, I guess, how people use things, and that drives some of this. But did you see a spike in downlink traffic because you switched off 3G?
No.
Okay.
No.
All right. Thank you.
At least, yeah. This is looking at the change in traffic on these different 4G, 5G, cells, and there's in practice no change, because on one hand you are moving 3G traffic to 4G, and then we were looking at these, mid bands, and there's no change. So then it's another question that how the capacity and traffic amount naturally grows by people's use of the network. But at least because the 3G was carrying so little traffic, then the impact in the other technologies was almost immeasurable.
Okay, thanks.
Okay. Then I think we've reached the end of this, and I thank you all for being here. Thank you for a lively discussion, and well, enjoy the rest of the day.
Bye.
Yeah, bye.
Bye. Bye-bye, and bye to everybody. Thank you to everybody who are on the call, on the meeting, on the session, who are remote and who are living through whatever time zone they are in, at whatever hour. Thank you for participating. And we look forward to your participation at the next IETF.
ESG, AKFI. I'm lost. No, but ESG, AKFI. I don't even. What was that again?
Okay.
I'm lost.
So I'm an independent consultant.
Okay.
However, I've been working with a company called AKFI.
AKFI.
Foundation